Today we will learn how to use our TI-84 to calculate probabilities using normal probability distribution. One way to calculate probabilities that follow a normal distribution is to use the standard normal distribution. In a standard normal distribution situation, you have to assume the population mean of 0 and standard deviation of 1. And the formula of any probability parameter x less than a is the integral from negative infinity to a e to the negative x minus mu squared divided by 2 sigma squared. The whole thing divided by sigma times square root of 2 pi dx. Now, if we want to look at how we can find areas, since integral mean areas, for certain standard values of z, you can calculate z equals x minus mu divided by sigma. Now, once we normalize that, we can actually find the area to the left or right of z values, and this is what it will look like once you do that. Now, let's look at case 1. If we are trying to find the area to the left of z, given by this formula of negative 1.93, this is what it means. You have to take the integral from negative infinity all the way to negative 1.93 and calculate this little area in here. Now, this actually is built into your calculator using the normal CDF button. The normal CDF button will calculate the areas up to that point. So what you can do is you can go and you can push 0.5 minus, which is going to be this whole area, and integrate from negative 1.93, which is here, to 0. So when you take away 0.5 minus this, you will be getting this little area right here. So I'm going to go and pick second distribution, and the normal CDF button is the second option. We are going to integrate from negative 1.93 to 0. When you close that and push enter, you will be getting the probability value that we are looking for. Now let's go and look at a case 2. In this case, we are trying to find the area between z of 2 and z of 2.47, right here and here. So we're talking about this little area in here. And since I know normal CDF button does take the integral and calculates the area between two z values, I will just go and use my calculator doing that. Second distribution. Second option is normal CDF. And you are going to integrate from 2, to 2.47. When you close your parentheses and push enter, that will give you the area that you're looking for. The third case is going to be finding the area to the right of the z value. So if a z value of negative 1.16 is given right here, if we are looking for this whole area, what you can do is you can go and you can calculate this area from here to here and add this area to it. And this area happens to be half of 1, which is 0.5. So what I will do is I will go and integrate from negative 1.16 to 0 right here, calculate this area, plus add this whole area to the right of the bell-shaped curve. So let's do that. So I'm going to go and pick second distribution, normal CDF, and we are going to integrate negative 1.16 to 0, and then add to that 0.5, and that will give you this 0.877 number. Now that we know how to work the mechanics of this, I'm going to do an example. The first example is related to garbage. So each month, an American household generates an average of 28 pounds of garbage. Assuming the standard deviation of 2 pounds, if a household is selected at random, find the probability of its generating more than 30.2 pounds per month. So the first thing I can do, I'm looking for the probability of the variable x being more than 30.2. So if you remember the formula, it's going to be, when you plug in the values, you have to integrate from negative infinity to 30.2. If we are looking at a curve like this, you have to take away from all the way negative infinity to that point, and that will be this area. Since I'm looking for more, you have to subtract that from 1. Now, since I want to use the standard normal distribution, you can take this whole formula and translate it into z value using this formula. So if I'm using this formula, x minus mu over sigma, I will be getting 1.1. So instead of 30.2, I have z greater than 1.1. So instead of the x, I'm integrating against z. So it's going to be 1 minus, you are going to integrate from negative infinity to 1.1. So I have to take this whole 1 and subtract this portion of the curve to get that little portion of the curve to the right. So if you remember the shortcut, what I can do is I can take this 0.5, which is right here, or think of it like this 0.5, and I'm going to take away this portion so that I have that little value. So you can go 0.5 minus normal CDF, and you integrate from 0 to 1.1. That will give you that little area to the right. So let's push that 0.5 minus, and you get the normal CDF from the distribution. The second option, enter. You're going to integrate from 0 to 1.1, and that's the value that we got before. So that would give you 0.1357. Now, if I don't want to work with the z's, and remember you have to do this by hand and integrate to 1.1. If you want to do, if you want your calculator to calculate the normal CDF value 0 to 1.1, but you want your calculator to find this, what you can do is, when you entered your normal CDF, you can enter your lower value, your upper value. Then you can enter the mu here and the standard deviation. Then your calculator, this is even a shorter cut than this first step, your calculator will calculate that probability directly. If you don't put anything here, the mu and standard deviation, it will think it's normal, standard normal, but if you put it in there, it will go and calculate the z's and integrate it against x. So let's try that. 1 minus normal CDF, go and take it from the distribution. You take the second option. You're going to integrate 0 to 30.2. And then you're going to enter the mu, which is 28. And then you're going to enter the standard deviation, which is 2. Close your parentheses. And that will give you the answer of 0.1357. Now, one last thing that we are going to cover is the central limit theorem. And you can see your derivation in your book or any other kind of standard statistics reference. So I'll assume that you'll look that up yourself, but I'll give you the steps to apply standard limit theorem with your TI-84. There are two things the standard limit theorem says. The mean of the sample mean is the same as the population mean. That's the first derivation. The second one is the standard deviation of a sample mean is the population standard deviation divided by the square root of the sample size. So if you remember how we calculated z previously, it was x minus mu over sigma. In this case, instead of x, you're going to use the average x minus mu, since the mean of the means is the same as the population mean. So this one is not going to change. But since the standard deviation is sigma divided by square root of n, you are going to use this instead of sigma. So let me show you an example. If a problem gives you a situation where you're picking a random sample of x number of something, you will be using this formula instead of the x minus mu over sigma. For example, the average age of a vehicle in the US is 96 months. Assume the standard deviation of 16 months. If a random sample of 36 vehicles is selected, so that will give it away. A sample is going to be selected. Find the probability that the mean of their age, not their age, but the mean of their age is between 90 and 100 months. So using this modified z, I can calculate the z corresponding to 90 and z corresponding to 100. So it's going to be 90 minus 96 divided by sigma, and then here is your sample size, 36 vehicles. The first one is going to give me negative 2.25. The second one is going to give you 1.5. So if my mean is between 90 to 100, that's the same as z going from negative 225 to 1.5. If you remember how we used the normal CDF button, that means all I have to do is just go use the normal CDF, the lower limit, comma, upper limit. So let's do that. Second distribution, normal CDF, lower limit, negative 2.25 to 1.5. And that will give you 0.921. Remember, the shorter cut was you don't use the z values, you use your x values, which is 90 to 100. But tell your calculator that this is not the z values, so you do that by entering the mu first. And this is going to be mean of the means in this case, and the standard deviation of the mean, which is the population standard deviation divided by square root of n. So if I enter it this way, rather than just entering these two things, the whole thing, your calculator will calculate the z values and calculate the probability. Let me show you. You go second distribution, you pick normal CDF, you go from 90 to 100. Now this time I have to let my calculator calculate the z's. So enter mu and enter the standard deviation, and in this case it's going to be 16 divided by, and you can enter this and let the calculator calculate everything, 36. And be careful with the parentheses. The square root will put the parentheses in here, but you have a second parentheses in there. So you have to enter two of them and push enter. And it will give you the same exact answer.